Remember when everyone thought the chip shortage would be over by now? Think again. It's 2025, and the world is still reeling from a crisis that began half a decade ago. From your smartphone to your car, from defense systems to dishwashers, microchips are the invisible foundation of our lives. But the global supply chain that powers this foundation is still fractured. Delays continue, prices remain inflated, and experts now warn this isn't just a temporary disruption, it's a fundamental reshaping of the global technological order. Welcome to Global Chip Shortage, Beyond 2025. A story of silicon, power, and the future of everything. It all began in 2020. The COVID-19 pandemic shut down factories, severed supply chains, and triggered panic across industries. When the world went into lockdown, demand for electronics exploded. Laptops, webcams, gaming consoles, data centers, automakers slashed chip orders, assuming demand would collapse, but instead it soared. And when they tried to reorder, the chip factories were already overloaded with electronics and cloud contracts. Fast forward to today, 5 years later, and we're still paying the price. Car manufacturers continue to face production delays. Medical device companies wait months for components. Even renewable energy projects and smart infrastructure are held back by the same tiny missing pieces of silicon. Why is it so hard to fix? Because making a chip isn't like making a smartphone. It's one of the most complex engineering feats in human history. Step inside a semiconductor fab, and you're entering a $20 billion clean room where even a single speck of dust can destroy a microchip. Building one takes 3 to 5 years, and the process depends on a microscopic ballet of physics, chemistry, and precision machinery. The biggest bottleneck? Equipment. Only a handful of companies, like ASML in the Netherlands or Applied Materials in the US, make the machines capable of producing next-gen chips. Each machine can cost over $150 million. Then there's the material chain: silicon wafers, photoresists, and rare gases like neon, all limited, all sensitive to geopolitical tensions. When any link breaks, the entire chain stalls. And that's why, even in 2025, production still can't keep up with demand. The chip shortage isn't just about supply, it's about power. Microchips are the new oil of the 21st century, and control over them means control over the global economy. The US and China are now locked in a technological arms race. America has banned advanced chip exports to China, fearing they could power military AI systems. China, meanwhile, is investing billions in domestic semiconductor programs to achieve tech independence. Caught in the middle is Taiwan, home to TSMC, the world's most advanced chipmaker, producing over 60% of global semiconductors. If anything disrupts Taiwan's production, even for a few weeks, the effects would ripple across every industry on Earth. Governments are now pouring billions into chip nationalism, building fabs on home soil, securing rare materials, and rewriting trade rules. But in doing so, they risk fragmenting a global system that once thrived on cooperation. Even as global supply chains struggle to recover, demand is accelerating faster than ever. Artificial intelligence, electric vehicles, and the Internet of Things are rewriting the rules of what we call the digital economy. AI alone has changed the landscape. Training a single large language model can consume tens of thousands of high-performance chips, each one optimized for speed, data, and power. Every advancement in intelligence demands a surge in silicon. Then there's the electric vehicle revolution. A traditional car once needed only a few hundred chips. Now, a modern EV can require nearly 3,000, controlling everything from battery systems and sensors to autonomous driving features. Multiply that by millions of vehicles, and the scale of demand becomes staggering. And beyond that, a quiet explosion. Billions of IoT devices, smart thermostats, security cameras, medical wearables, and industrial sensors are lighting up across the world, each one small, but together forming a vast, interconnected web of data and dependency. By 2030, global chip consumption could double once again. This isn't a short-term crunch, it's a structural shift, a fundamental reordering of the world's digital priorities. We are entering a new age, an age where demand perpetually outpaces supply, but strategic assets, the lifeblood of innovation, national security, and the global economy itself. To close the gap, governments are investing at historic levels. The U.S. CHIPS Act allocates over $50 billion to revive domestic semiconductor production. The EU, Japan, and India are following suit, building regional hubs to diversify supply. But scaling production isn't instant. Each new fab takes years to complete and faces the same equipment shortages plaguing existing ones. And there's another problem: talent. The industry is facing a shortage of skilled engineers and technicians to run these hyper-advanced facilities. The rebuilding has begun, but the finish line is still far away. Beyond 2025, the world faces a new reality. The global chip shortage may never truly end. It's evolving into a new normal. We're moving from scarcity to strategic management, from just-in-time to just-in-case. Future chips will be smarter, smaller, and more efficient, but their supply will remain at the mercy of politics, economics, and innovation. The microchip is no longer just a component, it's the pulse of modern civilization. And whoever controls it, controls the future. If you believe in innovation, in progress, in the power of ideas, then don't just watch the videos, be part of it. Press the like button and subscribe to step into the future with us.